Hey, I'm gonna talk a little about the discount rate. So I have a really simple example here where we have free cash flow, and this one is to equity. What kind of discount rate do you use for this to equity? Well, in this case, it's a levered DCF, so it only uses cost of equity and it doesn't take into account capital structure because it's already built in. What is cost of equity? As you can see in the first picture here, you have the equity ratio times RE, which is the cost of equity. And if we can make this one a little bit bigger, like that, and you can see here, you have the risk of equity, cost of equity is the risk-free rate plus the beta times the market risk, expected market risk, minus the risk-free rate. So to be honest, I find it very straightforward. In the beginning, I made it more complicated than it is, but it's a formula, and you can obviously, if you become really good at this, you can quantify this. You can have a system, essentially where you have the same kind of, for instance, if you say, you have company A and company B. Company A has a beta of 1, this one has a beta of 2. But the market risk is always the same, right? So let's just say it's 6%. And the risk-free rate, which is, you could say it's the same as the T-bill, treasury bill. So for Sweden, it's, I think it's like 1.7, like that right now for the Swedish stock market. So yeah, now we want to calculate the risk cost of equity here. So what we do here is we take the risk-free rate plus the beta times market risk minus that one. And obviously you have to do it like that, pull it to the right. Something happened here, I think. No, exactly, because this company has a lot higher beta. It obviously means, according to this model, that it's a more risky asset, essentially. So, is this the correct way to do it? How do you know what the market risk is? Stuff like that. And usually what I do, in Sweden, you can obviously look at many different sort of material, like Asford Dammerdaren has some pretty good papers when it comes to illiquidity premiums, which I will get into in a moment. But first, you have something that is called the risk premium study. So I'm just going to download it. Oh my god. Open with, there we go. My paper. Okay, let's see. So this study is only in Swedish, which is kind of weird. So I reckon there are others like it, but this is just what we use a lot in Sweden. So the Swedish side, you'll find some summary points somewhere. Let's see. Here, you have a conclusion of this year's study. So what they do is they ask many different sort of people about what kind of inputs they use when they perform valuations. And as you can see, it includes corporate finance, fund investment banking sort of equity portfolio managers, risk capitalists, and so they put together all these answers and they come up with something like this. So in total, they say that the people who answered this poll, or whatever you could call it, they said the market risk premium was 6.5%. And so what do we have more than that? If we were to change this one to 6.5%. So is the risk-free rate fine as it is? Let's say the treasury bill in Sweden is this amount. Is it correct? Well, if you look in a time perspective, you've noticed drastically falling rates to the point where almost negative. So in this, you can see the people who answered it said they used a normalized T-rate bill. So what we said is the people in this year's study reckon that a normalized long-term risk-free rate is in average 2.9%. And after that they say it's definitely higher than the average rate of a Swedish treasury bill, 10-year. That was at roughly 0.7%. So what you can see here is, if you use the normalized risk-free rate, at 2.9%, like that. So you can obviously have O1, U1. Just pull them down, and we need to. That was stupid. Nice. Like that. Just change it back. So the difference isn't really that big when it comes to this one, for some reason. Intuitively, but when it comes to higher beta values, you can see that the old one had a higher discount rate. Does that make sense? Yeah, okay, so since this value is higher, you'll have a part of the equation that is always higher. While if you have a beta value of 1, it will just reduce it by the same amount. So if you change the risk-free rate and the beta is 1, nothing will change. But when it comes to higher beta values, you'll have a lower cost of equity. So yeah, it really, if we were to change that one to, okay, so for if you have a problem with lower betas and such, this methodology would give you higher discount rates, while for seemingly more risky assets it will be more positive to them. So we have new one with normalized TV. Perfect. So we have 2 discount rates now. Is that all? Well, what I like to do is have a liquidity premium. When it comes to small companies, they are usually very liquid. And generally in this study, they have something called a size-related risk premium add-on, which is essentially the same as a liquidity premium. So what they say is if it has a market cap over, it's hard to, but when I do it, I usually think of it as all the companies that have a market cap over $500 million. You have a very small risk premium add-on of 6 promille or 0.6%. If you have smaller companies, you suddenly have higher risk premium add-on at this amount. And if you have a really small company, like for say if it's the market cap is lower than 100 million kroner, you'll have a risk premium add-on of almost 4%. So let's just assume the company A has a price of 100, and this one has a price of maybe in terms of market cap in. So there's other ways of dealing with this. I usually have like an if statement for all these, but let's just make it easy. This company has a market cap of 100 million kroner. So essentially you should add this value because it was conducted at a latest study, 3.8%. So risk liquidity risk premium addition. This company had a market cap of 10,000. Jesus, 100 million, 10 billion kroner. That sounds weird. Yeah, anyways, it's higher than this value, right? So I'll just use this one. It might be higher, but I usually go after these ones. So great. What do we do now? We have our risk premium. So what I usually do is I add it to the parenthesis, which is subject to the beta. There we go. We can actually have do like this: new one with normalized T-bill and liquidity. I'm just gonna call it LRP, this liquidity risk premium addition. So you can just copy this formula, and here you add it on like that. Suddenly we have a lot higher. If you were to do your CAPM and your cost of equity on a really small company, you got a discount rate on at 6%, and you looked at several other equity research reports from whatever, and you saw that they used a lot higher. So essentially, you know the riskiness of a company is a lot higher than the CAPM insinuates, and this using liquidity risk premiums is a way of making the discount rate correspond with the actual riskiness of the stock. So in this case, we'll do the same. Yeah, so here we have three cost of equities, depending on how you do them. All the one with some very basic CAPM, and other ones that, and ultimately these ones that may seem intuitive, since the company has a very high market cap. I doubt the beta is 2, so it's probably like that, but let's just assume it's 1. So as you can see, the liquidity risk premium addition has a large impact on the finalized cost of equity if you go with this method. Yeah, so that is it. Thank you.